Hello! In this integrity video, we are going to practice sketching functions that have been shifted vertically or horizontally, that have been reflected across the x or y axis, and that have been stretched or compressed. So, let's go ahead and talk about how we do this. A couple things. First thing I want you to look for is to determine what kind of function it is and think about what the parent function would look like. So I look at this first function, and the thing that catches my eye is that exponent. What that exponent tells me is that we're dealing with the parent function would be y equals x squared, which means I have a parabola. Then the question becomes, what are we doing to this parabola and how have we made it different? When I'm trying to figure out how the function has been adjusted, the first place I look at is the x piece. I want to figure out how I can zero out this x piece right here. What that does is that tells me where I should be starting my graph. So in this case, I look at this and I say, okay, well, how can I zero out that blue part, that part that's grouped with x? Well, when x equals positive 1, this whole thing is gone, and I can see that y equals 3. This is the location of the vertex of my parabola. And what this means is that my graph has been shifted. Here I'm going right 1 unit, and this tells me I'm going up 3. So I'm going to plot that here. Right 1, up 3. Notice that there is no coefficient in front of this x piece. This tells me that I am not stretching or compressing my graph. I'm not going to be reflecting it. This is just going to be a normal parabola. It's going to have the same shape. The only thing we've done is we've moved it to the right and we've moved it up. Everything else stays the same. Now, what I'm looking for at this stage is just a sketch. I'm not too worried about getting all those lattice points in place. Right now, I just want an idea of what this thing's going to look like. Let's go to the next one. Again, we want to figure out what kind of function it is. The thing that catches my eye is the fact that we have a fraction. I have a fraction, and x is in the denominator. So this makes me think that the parent function is y equals 1 over x, which looks like this. Then the question is, how have we modified this function, and what does the new one look like? Couple things. I want to figure out how to zero out this x piece. The reason why is because if I can make this x part become 0, I know that I would have 1 divided by 0, which tells me where my asymptote is. So 2 minus 2 gives me a vertical asymptote. That tells me that my asymptote is at x equals 2. Notice we haven't added anything here or subtracted anything to the function. Because there's nothing that's being added or subtracted, there's not going to be any vertical shifting, just this horizontal shift. And actually there is one other change. I'd like to draw your attention to the fact that x is negative. When x is negative and we have f of negative x, we are reflecting across the y-axis. So I like to think of it as, instead of using positive x values, we end up using negative x values, and it turns my function, it reflects it. So when I do that, and my graph is being reflected, I end up with something that looks like that. Let's go ahead and do another one. What kind of function is this? Well, the part that catches my eye is the fact that I have a cube root. And we can refer to our parent function page if you're not sure what a cube root looks like. Or we can make a quick table and think about what our parent function actually does. If I have y equals the cube root of x, I would want to choose some values that I could easily take the cube root of. For example, suppose x is 8. Well, the cube root of 8 is 2. And just by doing a quick check, I can figure out what some values are here. If x is negative 8, then y is going to be negative 2. And again, if you're not sure, this will help give you an idea. So my parent function is going to look like that. However, this function has been modified a little bit. We're looking at the part with x. How can I zero that out? Well, if x is positive 1, then y is 0. So I'm going to graph that in blue. If x is positive 1, y is 0. And what this tells me is that I'm taking my function from here and I'm moving it to the right 1 unit. So let me erase this parent function and draw in the cube root function. And again, we're just sketching. Doesn't have to be perfect. But this would be the cube root function with the horizontal transformation. Let's go ahead and look at the next one. What catches my eye here? That exponent. We're dealing with another parabola. So, what are we doing to this parabola? How have we changed it? I always like to zero out this x piece. Well, the good news is that's really easy to zero out because it's just 0. If x equals 0, then this whole thing goes away, and I can see pretty easily that y equals 1. This is a vertical shift, so my vertex for the parabola is at positive 1. Let me erase all this stuff that I've written here. Whoa, there we are. Okay. Couple other things I notice. That negative sign tells me that my parabola is opening downward. This 1/3 here tells me that my parabola is going to be wider than normal. Now we're just sketching. I'm not going to get too particular at this point. I just want to feel for what it looks like. So I'm going to exaggerate this. I know it's opening down, and I know it's a wide parabola. That is certainly a wide downward opening parabola. So for our purposes, that's going to work. Let's go ahead and look at the next one. Number 5, we have a square root function here. What does the parent graph look like for that? If I have y equals the square root of x, that's going to look like that. How have we adjusted it? Well, a couple things. First thing, that negative sign tells me that instead of opening to the right, it's going to open to the left. The fact that I have a +3 tells me that instead of starting at 0, we're going to start up at positive 3. So, pulling that all together, this graph is going to look something like that. Number 6, what kind of function is this? Well, this is an absolute value function. The parent graph for that is y equals the absolute value of x. And that is a V-shaped graph with the vertex at the origin. But this has been changed. How have we changed it? Well, looking at this, this tells me that we're going to go up 3. And this might be harder to identify because the order has been switched around. So what I'm going to do is I'm going to just erase this and rewrite the function in the order that is maybe a little easier to identify. We could say f of x equals -2 times the absolute value of x plus 3. Now that looks more like what we've been working with. Same thing for number 5, actually. I could have rewritten it as f of x equals the square root of -x plus 3. That would have been fine too. So, what are we doing here? We have, if I wanted to zero out this x piece, I could say that when x equals 0, this whole thing goes away, y equals 3. I have a vertical shift of positive 3. That negative 2. That negative 2 tells me that it's going to grow at a faster rate. It's going to be more narrow, right? We're stretching this graph. And the fact that it's negative tells me that it is opening downward. So, pulling this all together here, and actually, because this is an absolute value function, that negative 2, it acts like slope. We're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And that is how we have changed this function, this parent function here. We moved it 3 units up, flipped it upside down, and stretched it. And that's going to conclude the practice for this evening. Thanks so much. Bye.